show that problems. In the show that problems, something you must know very clear, that is the formulas, then how the ratios are to be used, and so on. All the things will be discussed in this lecture. Now you know the list of the formulas which we have already studied in the previous lectures, some of the ratios. So those formulas now here, those formulas are complementary angle formulas, that is sine theta equal cos 90 minus theta and so on. So we have the formulas here. Now in these formulas you try to focus on this. Just I'll get the marker here. Pointer it is, sorry. So complementary angle, the first two formulas which are shown in blue color, just see, sine theta is equal to cos 90 minus theta and cos theta is equal to sine 90 minus theta. Then we have somewhat violet color formulas related to sec and cosec. So cosec theta equal cos 90 minus theta and sec theta, and cosec theta equals sec 90 minus theta. So these are the relation between sec and cosec. Then we have tan cot. So tan theta equals cot 90 minus theta and cot theta equals tan 90 minus theta. So these complementary angles related formulas, you have to focus, they are related sine cos, sec cosec and tan cot. Whereas when you look with the identity formulas, you will find that as in the complementary case, the relation is between sine and cos. The first formula is similar, that is the relation is between sine and cos. Whereas for the next two formulas, the sec and cosec, they are not related here. Your sec is related to tan and your cosec is related to cot. So here you have to be careful in your identity that whatever we are doing in complementary angle, or the way of thinking in complementary angle is sine cos, sec cosec, tan cot. So when we go for identity, the same is not there. It is sine cos, okay, but sec and tan and cosec and cot. Then we have seen these inverse formulas. These are also very important. In inverse, the relation is totally different. It is not the same case as you run the by-hearting things in your complementary angles and identities. Sine cosec, then cos sec and tan cot. So here again some type of confusion may be there. So you have to clear up yourself. Be sure what you are using in that. And then the tan formulas that will be discussed now in due course. And then we have these ratios from where we started. Without this, nothing happens. So these ratios, you have to be sure that the ratios are taken very clearly. Now, we will discuss the things which are necessary for the show that problems. First, we shall discuss few ratios. Now, the ratios which we have studied was sine ratio, cos ratio, tan ratio. There are another three ratios. Now, this sine ratio, the inverse of it is related to cosec. So cosec ratio is the inverse of sine and sine ratio is the inverse of cosec. Similarly, for cos, the inverse is sec, and for sec, the inverse is cos. Okay, and in the same way, for tan ratio, the inverse is cot ratio, and for cot ratio, the inverse is tan ratio. The similar things can be seen in the inverse formulas here to the right hand side of your screen. Now, here you try to focus some important things which I am going to tell you, that our cosec ratio in the inverse formula is written as cosec is equal to 1 upon sine. The angle may be theta in both the places, or you can write cosec A 1 upon sine A. So the angle can have a name or some measures can be written here. So this have to be a very common thing, it is there. Always theta will be there, it is not so. Then the next is your sec inverse. So sec inverse, that is sec theta, is equal to 1 upon cos theta. And now in case of tan and cot, we will be writing these formulas which are there in the bottom right hand bottom side. So those formulas are written here. Tan theta equals sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. Now here the important thing to remember is, be careful, on the left hand side we have 4 ratios, that is cosec, sec, tan and cot, whereas on the right hand side you get only 2 ratios, that is sin and cos. So here all these 4 ratios can be converted in sin and cos. In short, we can say this. So you will find that here we have sin, cos, tan is using both of them, and cot is also using both of them. So here when you come back, these ratios, cosec, sec, cot and tan, can be converted in sin and cos. So here we say that this sin ratio and cos ratio are the basic ratios. So here we have our basic ratios are sin and cos. You have to remember this. Now remember one important point. This is our understanding that these are basic ratios. In trigonometry, such type of words are not used, that sin and cos are the basic ratios and something like this. So that things are not there. Okay. Now we shall move to the other set of formulas, that is identities. So we will take the first identity. So our first identity is sin square a plus cos square a is equal to 1. Now in this identity, if you see carefully, it can be converted in 2 more forms by transferring either sin or cos to the right hand side. Now if you transfer cos square a to the right hand side, you will get sin square a equals 1 minus cos square a. So this becomes the value of sin square a. From the same formula or identity, you can obtain the value of sin square a in terms of cos square a. Then similarly, you can also obtain the value of cos square a. So cos square a will be equal to 1 minus sin square a. Now wherever there is sin square a or cos square a, you can replace it as required by 1 minus cos square a, and cos square a can be replaced by 1 minus sin square a. Okay, now we shall see the second identity, that is sec square a minus tan square a equals 1. These identities can also be replaced, we can also write them in 2 more forms. Now when you transfer this minus tan square a to the right side, it will become plus. Okay, and then you will get the value of sec square a. So here it is sec square a equals 1 plus tan square a. Now when you transfer this sec square a to the right hand side, it will become minus. But what happens it's that the tan is having the minus sign, and we know very well this minus sign is a problem for most of the students. Therefore we shall try to get the value of tan by using the sec square formula itself. So now here what you do, that transfer this 1 to the left side, so that you will the left side will become sec square a minus 1, and on the right side will have only tan square a. But while writing, we will write the tan square a here and write the sec square a minus 1 on this side. Okay, so it will be tan square a equals sec square a minus 1. So these are the 2 forms of the second identity. Now the third identity, cosec square a minus cot square a is equal to 1. So here you will note that on transferring this minus cot square a to the right hand side, as it was done in the above identity, you will get cosec square A equals 1 plus cot square A. In the same way, to avoid the confusion of this minus sign, we will transfer this 1 to the left side. So it will become cosec square A minus 1. And what remains on the right hand side is cot square A. So write the cot square A here to the left side, and on the right hand side you can write cosec square A minus 1. So here you can note that all identities, all the three identities can be written in two more forms. So your identity will have somewhat 9 different types of formulas built in it. Now try to focus on the identities again. You will find that each and every identity is equal to 1. That is sin square A plus cos square A is equal to 1. Focus on this 1. Then we have sec square A minus tan square A is equal to 1. Again focus on this 1. And then we have cosec square A minus cot square A is equal to 1. So now we shall take this 1, and this 1 in the show that problem you can replace by either of these identities. Now see, it is shown on your screen. 1 can be replaced by sin square A plus cos square A. 1 can also be replaced by sec square A minus tan square A. And it can also be replaced by the third identity, that is cosec square A minus cot square A. So in this way, in some cases, you may feel it necessary that 1 is to be replaced. So you can use any one of these particular identities. Fine. Now, after this, we shall also look for some formulas which you have already studied in your lower classes. That is your 6th or 7th standard books, it will start. Those formulas are related to your expansion formulas and factorization formulas. Just we'll revise them. So here the expansion formulas are there. So the first formula is A plus B, the whole square equals A square plus 2AB plus B square. Then you have the second formula, A minus B the whole square equals A square minus 2AB plus B square. Now in the formula, the minus sign is shown by red color, because generally you will find that most of the students, they go wrong whenever the minus sign comes there. So this minus sign is, I have indicated it by red color in most of the places. Here in the top case also you may find that the signs are generally written by red color, so that you must focus on the signs. You need not make any mistakes there. Then the next formula is the cube formula, that is A plus B the whole cube. So A plus B the whole cube is equal to A cube plus 3A square B plus 3AB square plus B cube. Now you will find that this formula in the textbooks may be written in some other form, that is they may show some brackets here and there. It is an expansion formula, and I always feel that in the expansion formula brackets must not be there, because the logic is when you expand it, the brackets are to be removed. That's the meaning of expansion. Expand something means the bracket is to be removed, and if you are going to factorize something, it is the inverse of your expansion, that is make brackets. So when you are factorizing, you have to make brackets. When you are expanding anything, you have to open the brackets. So there must not be any brackets in the formulas. Now look at this way in which the formula is written. If you look at the A terms, it is A cube, then A square, then A raised to 1, and then A raised to 0. And A raised to 0 means the value is 1, therefore 1 is not written. Any multiplication of 1 is the same term. Whereas in case of B, it is going down. 3, that is B cube the last term, then B square, then B raised to 1, and then here you will get B raised to 0. So you will find that in each and every term, AB is there. But in the first case, since the index is 0 and whenever the index is 0, the value of the term is 1, so it is not written. Then b raised to 1, b raised to 2, and b raised to 3. And then we have for the middle two terms the coefficient as 3. Same type of concept is been working here. Here you'll find it b raised to 0, b raised to 1, b raised to 2. And it is a raised to 2, a raised to 1, a raised to 0. And then the coefficient here is 2. For a plus b the whole square and a minus b the whole square, the same type of concept is there. Then we will be having one more formula, that is there, a cube minus b cube. So a cube minus b cube is equal to a cube minus 3a square b plus 3ab square minus b cube. Same way the formula is written. And you have to note here that b, wherever the power of b or the index of b is an odd number, here it is 1, here it is 3, those terms are having the negative sign. Because whenever the power is even, 2 or 0 here, you will find that minus sign multiplied 2 times becomes plus. Okay, so therefore when the power of b is a negative term here, if the power is an even number, definitely it will possess a positive sign. When the power is odd or the index is odd, you can say it will have a negative sign. So these are some of the expansion formulas you have to remember. Then we shall move to the factorization formulas. Now the factorization formulas are a square minus b square equals a plus b, a minus b. So this is a factorized formula which you have used number of times. Then the next is a cube minus b cube. It is a minus b, then it is a square plus ab plus b square. So this you have to memorize. And then we have a cube plus b cube. So this factorized formula is a plus b, and then we have similarly a square minus ab plus b square. So I think here it must be a square minus b square, a cube minus b cube, a cube plus b cube. Okay, it's all right. So the factorization formulas are there on your screen, expansion formulas are there. So this is some part in the preparatory lecture which you must remember it very well. All the things are on your screen. So much things must be always running at the back of your mind when you are solving the show that problems. You can write those things on your cardboard sheets and keep it ready whenever you are solving these problems. Now just I will have a fast revision that sine and cos are the basic ratios. So this point always you have to remember that whenever I am solving problem with you, I will be using this number of times that go for basics, convert those things in the basic ratio, something like this. Okay, then these identities, the 3 identities can be written in 2 more forms. This also you have to always remember. Then replacing 1. Sometimes we find that 1 is replaced by one of these identities. Okay, so this is these are the things we can say where you must remember before we go to the part of solving problems. Now, so this lecture, this was the thing I find it necessary to explain to you. In the next lecture, we shall deal with the problems, and you will find that I am using all these things, whatever there is on your screen. So, thank you very much for watching. If you like this video, press the like button and subscribe to my channel, that is Kit Classroom. Thank you for watching. It was Life with Khandekar sir. Good night.